When you're watching this video, just make sure that you understand that when I'm talking about the tire's diameter is 40 inches and that the tire's radius is 20 inches. So it should say if the 40-inch tires of the car and then the 20 is the radius. So the work is done assuming that the radius is 20 inches. Linear and angular velocity. So if I'm looking at this, these are two formulas that are pretty much the same type of formulas. You're familiar with this one here. This one here is the radian formula, which we also call the arc length formula for S, or the radian formula because the angle has to be in radians. So when we're talking about the arc length, it's going to be measured in centimeters or meters or miles. The angle is always going to be measured in radians. The radius is also the same thing. If this arc is being measured in centimeters, so is the length is going to be centimeters. So this is just a straight basic little formula. And so when we're talking about something like a car and the wheels or anything that's circular that's rotating, we have a rate at which it's rotating. So it's going to be the distance covered in time. So like miles per hour. So the wheels are traveling at 50 miles per hour. And so the angular speed is how many times it actually, the angle is being made. So every single time that a wheel turns around and makes one for complete rotation, it's 2 pi. So how many radians is it making every hour, and so or every minute or every second. That's the difference here, but still this angle and this angle are both the same. So the theta here and the omega here, they're radians, but this one here has a time about it. It's a rate. And then this length and this v, they're the same thing. This is the distance. This is also the distance, but this is the distance per time. And then the radius doesn't change. So the radius of the wheel is still going to be the same length, meters, centimeters, inches, whatever it is. So these two formulas are exactly the same two formulas, except for this here is the rate at which something is happening. So let's do these formulas on here. Let's apply them to these problems. So we have a tire on a car that's 20 inches and it's traveling at 55 miles per hour. I know that this is the linear speed because it is, the rate is 55 miles um, 1 hour. So it's miles distance per time. What is the linear speed in feet per hour? So in this case here, we're not even using the formulas because we already have the linear speed and they are asking us for the linear speed, but in different units. So all this is a dimensional problem. So when you do this, you're going to have 55 miles in 1 hour, and we're going to need to change it to feet per hour. So we're going to leave the hour alone. The only thing that we want to change is the miles. So miles is going to be at the denominator, and then we're going to change this to feet, and we know that it's 1 mile and 5280 feet, which that's what's given to us right there. And so then the miles are gone, and now it's going to be in feet. So now when we calculate that, we multiply it across, we're going to get 400 feet in 1 hour. But then it tells us more. They wanted it in inches per hour. So now this is feet per hour. We need to get it into inches per hour. Now, because they ask us to do it first in feet, that's why it was. Otherwise, you could have gone straight to inches. And so we know that feet go down here and inches go up there. So there's 12 inches in 1 foot. That's the conversion units. And so that's where we get that. And so we multiply that out and we get 3,484, 800 inches in 1 hour. So we have about 3 million, almost 3.5 million on there. So it's going to be the linear speed is 3,484, 800 inches per hour. And that is your sentence there. Very good. Next one, if 20, we got the same tires, 20-inch tires on the car. It's also traveling again 55 miles per hour. So this here is your linear speed because it has distance and time. What is their angular speed. So what it's asking right now is the angular speed, which is the angle. How many radians per time is it happening? So how am I going to figure this out? This is where I would have to use the formula because that's the relationship. Linear speed, angular speed, and then the radius. I know that the radius, 20-inch tires, that is going to be, that's what when they say 20 inches, the radius there, not the diameter. And so what we do here is going to be that the linear speed, well, we already calculated the linear speed in inches per mile. So you have to decide, do I want to use the feet one or do I want to use the inches one? But since our car is in, the tires are in inches, the inches is the one that we want to use. So the linear speed here is going to be 3,484, 8,000 inches in 1 hour is going to equal to, I don't know what omega is, but I know that this here is going to be 20 inches. And so that's your R. And now we're just going to divide that into that. And we are going to multiply this by 1 over 20 inches. We're going to do the same thing, 1 over 20 inches. The inches are going to cancel. And once the inches cancel, because we're dealing with an omega, this automatically is going to put it in radians because that's the formula. It's still the S equals to theta R, just with the rate. So when we cancel and we reduce there, we end up with 174, 240 radians in 1 hour. And that is going to be your omega. And then we just write the sentence on there. The angular speed is 174,240 radians per hour. Now, it also is asking us here degrees per minute. So you're just going to do the dimensional analysis on there, and you are pretty familiar with that. I'm just going to set it up. And it's dimension degrees per hour. We're already in hours. So this is radians. And then this one here is going to be radians down here. This is going to be degrees. So we're going to do 180. And then this is going to be pi. And then you calculate the numerator and you calculate the denominator and you get your answer. And you have the other sentence on there. So that's a dimensional analysis. Now you're going to be in degrees. So multiply across and then divide by pi. And that's going to be degrees per hour. Very good. In the next one here, it's going to be 20 inches. Again, the tires are 20 inches and they're traveling again at a linear speed of miles per hour there, 55. They want the rotational speed and rotations per hour. Rotational speed is similar to the angle, and the rotational speed is how many times the wheel actually rotates. So if I know that it's going by, we're going to be using the radian measure. If we're using the radian measure, I'm taking this and we're going to take the 174,240 radians and then in 1 hour, and we're going to do the dimensional analysis. Well, the radians are back here, up there, so we're going to put them in the denominator there. And then on the top, it's going to be rotations. Well, how many radians are in one rotation? And it's going to be 2 pi. So the relationship between rotations and radians is that it takes one rotation is 2 pi. So the radians are going to cancel. And then you're going to be able to solve that. And it's just a simple dimensional analysis. And it turns out to be approximately 27,731.2 rotations in 1 hour. So you could say it's approximately um, their rotational speed or rate is about approximately 27,731 rotations per hour. And there we go. And then one more, if the 20-inch tires on the car are rotating 900 degrees per minute, how fast is the linear speed in inches per minute? So what we're doing here is we want to find the linear, so we want to find out what V is, and we want to do it in inches per minute. So this is pretty good because this is already in minutes. So when we use this formula, V is equal to omega R. We know it's 20 inches on there. And then the omega, that's going to be 900 degrees. But because it's omega, we can't use the 900 degrees. We have to convert 900 degrees to radians. So it's going to be over 1. And then this is degrees 180. And then this one here is going to be pi radians. The degrees are going to cancel. And it turns out that it's going to be 5 pi radians. And oh, I guess we could put the minutes in here and then per 1 minute. And so we end up that that's going to be your omega because now it's in radians. So we want to know what V is. So we're going to do 5 pi per 1 minute. So it's radians per minute. And then times the 20 inches. And so when we cancel this, when we multiply this, the radians go away because velocity, the linear speed, the velocity in which the car is going to be in distance per time. So the radians automatically go away. And so we have V is equal to, when you multiply it, about 314.2 inches per minute. So the linear speed velocity is approximately 304 inches per minute. And that's how fast it's going. And there we go. Okay.